Hello and welcome to the last lesson in Unit 3. Today's topic is the applications of regression and critical analysis. And this is going to be the more challenging of the lessons from this unit because it's going to require you to use all the skills that you've got up to this point, and you need to be able to look at the big picture and make that connection. So the learning goal. By the end of the homework and the lesson, I want you to be able to apply regression to a real-world situation, and that should go all right since it's the last 3 lessons. But the tricky part is going to be analyzing the resulting regression and drawing appropriate conclusions and recommendations. So that's going to be the challenge right there, is being able to complete that. So why do we need to be able to do this? So we often see news programs and newspapers and other forms of social media, whether it's the internet or whatever, and they use statistics. And the media uses statistics as a tool to shape our opinions. So very, very, very important that you can critically look at statistical analysis and determine whether it's a valid opinion or whether it's been skewed or biased to serve the purposes of the article. So that's going to be the challenge. I've got 3 examples that I want to run through with you. So the examples give you an idea of the 3 major areas here, 3 areas of interest. Number 1 is sample size and technique. So that speaks to our project, and I want you to see some of the errors that may come from, or errors that you can avoid in your project. Number 2 is talking about extraneous variables and sample bias. And finally, the 3rd one is hidden variables, variables that weren't taken into account when the research was done. So those are the 3, and those are the 3 specific examples that we're looking at. So the first one is a sample size and technique example. So the example itself, a manager wants to know if a new aptitude test accurately predicts employee productivity. So the manager had all 30 employees complete the test and then compared the scores to their observed productivity on their performance appraisals. So the employer arranged all the collected data alphabetically by employee surname. He then chooses a systematic sampling technique, similar to the one we've talked about in the project itself, and he's going to choose every 7th employee on the list. So he's arranged them alphabetically, and he's taking every 7th. So he does have one of the strategies we talked about for sampling. He's using it properly. Based on the data, the manager concludes that the company should only hire applicants who do well on the aptitude test. So he says that this method just shows that the process does work. So our job is to determine whether he has a valid case or not. So what we're going to do is we're going to take every 7th piece of data, and I'm going to start with this one. So we'll take, that's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Sorry, I'm off by 1 there. That's 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I'm off by 1 again. And there we go. Now I'm on there. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1. So those are the pieces of data that we're going to use to match up or see what the manager came out with. So if you want to get the graphing calculator out and enter that data in, and I will wait for you to get that finished and do it myself. All right, I have the data entered into the calculator, so I took every 7th, put it into the calculator. Remember, make sure your calculator has the diagnostic tool on. Make sure that you've done the scatter plot so it'll show up. Once you have the data entered, we go to Window, and I've already got it set up going from 0 to 100, 0 to 100. Now the data doesn't go down that low. I'm probably going to bump it back to 50. And I think the lowest score, I think there was a 47, so let's go with a 40. And when I graph it, here's my scatter plot. Now a couple of thoughts come to mind right away, and what I'm going to do is I am going to take a picture of that so I can bring it into the note and have a discussion with it. When I'm looking at the data though, and come in here. So when I'm looking at this data as it stands right now, I have some questions in terms of what the manager exactly was looking at, because when you look at the graph itself and you're looking at a line of best fit, you're looking at a line that kind of looks like that, from my opinion, and I wouldn't consider these pieces of data to be overly close, but it could be the scale. You're never sure. So then we go back to our graphing calculator and we do the diagnostic on it. So we go back to stat, we go to calculate, and we want to see if there's a linear relationship. So doing the linear relationship, I now get this information. So with the linear relationship, if I take another picture of that just to bring it into, so that I can draw on it. All right, so when I look at it, this is the result, and look at the R value. Remember, we're back to linear, so it's the R value that's important here. The R value is equal to positive 0.06, so it's almost 0, so this is pretty much no correlation. So why did the manager, when he did his statistical analysis, why did it work for him? Well, if we go back to the data, and instead of picking the first out of 7, I'm going to redo it now, and instead I'm going to pick the 7th piece. So 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. 1, 2, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now I'm going to go back to the graphing calculator. I'm going to re-enter the data that he did as well. So I'll give you a second to do that, and I will do it at the same time. And we'll meet back here. Okay, returning back to the example now, I've got the new data in, so if I would have taken, instead of taking the first piece of every 7th data, now I'm taking actually number 7. First thing I notice, I've gone from 5 pieces of information down to 4. I'm going to maintain the same window, and now I go to graph that scatter plot, and what I find is something kind of shocking here. When you go to graph it, all of a sudden you get a lot prettier line than we did with the previous data that I grabbed. So now, if I was the manager looking at this particular graph, so this one up here would be first of every 7. This is the 7th. And now I'm like, oh, well, there's a line, and you know what? There's not a whole lot of discrepancy between those points. So when I go to do the analysis with the graphing calculator, we go from a 0.06, which is virtually, that's in my books as 0. And when I do the calculation now to do that linear regression, all of a sudden it goes from 0.06 to 97, to a 97% correlation. So what does that tell us? It tells us we need to be very, very careful when we're selecting our data. So we're looking at or analyzing what the general manager was looking at when he's coming up with these conclusions. So let's just talk about some of this stuff. First of all, sample size plays a big role. So now when we're looking at the actual data, if I go back to the data itself and we're looking at it, we're looking at pretty much, what do we got? One, 2, 3, 4 groups of data there, 4, 7. So you're looking at roughly 30 pieces of data. So is every 7th piece of data, is that something that's representative? Well, if you're dealing with 30, I don't think he applied the systematic process quite right, because when you're taking 5 out of 30, you're only looking at a very, very small percentage. So sample size plays a big role. Okay, for small groups of data, in our case, approximately 30, taking a large gap, and in our case, we're talking about 7, may not be appropriate. All right. And if you give me 1 second, what I'll do is I'm going to just enter in all the data, because 30 is not unreasonable to enter in. Maybe with the calculator it seems a little bit daunting, but if you're looking at it in terms of a spreadsheet when we do the project, 30 pieces of data to take a part of that, we're already taking that 30 is a part of the school that you're surveying, while 30, if your company only has 30 employees, it's not a very, very large sample to start with. So to take a portion of those 30, if you're only going to take 4 or 5 individuals, it's not very representative. So I'll just quickly pause it here, and then I'm going to enter in all the data so you can see the comparison when you look at it that way. Okay, I've gone ahead and I've entered all the pieces of data in there. So now when I go to graph it, now it's really apparent that it's a whole lot of nothing. There's no way to draw a graph within that region, or sorry, draw a line within that region that would show any semblance of actually representing a linear relationship. So one of the critical things here, so be aware of sampling bias, and especially in your own project. So therefore, the manager should not conclude that a score on an aptitude test, a score on a test, reflects productivity. His error stems from sampling bias. All right. So very important, if he showed you that statistic, again, if we go up to that statistic that came out of it with the 4 that he took, it's a pretty heavy support there when you're looking at it. Geez, in 0.98, there must be a direct relationship. But when we took our initial data, it was virtually 0, and you're just taking almost the same number of data. So very important. So be careful with sampling bias, and a big thing when you're talking about a very small group that you're looking at, okay, that subgroup will vary quite a bit in there. All right, so there's our sample or example question on sampling bias.